Okay, so it was really, really lovely that you're all here spending your Wednesday evening with me. I have to say that I've not been feeling very well today, and so I apologise if I'm not my normal bubbly self. I have got one or two students of mine that are definitely in the audience today, so they'll know. So anyway, I would like to introduce. This is my lovely assistant. She's also my daughter. This is Megan. If you've got any messages, please pop them into the chat. She is Meg42 Tutoring for obvious reasons, and yeah, she will answer your messages as well as she can. I think she's already put a message in there. Yes, she has. Please keep your cameras and microphones off. And answers need to go into the chat, and you can type them in, or you can put them on a piece of paper and keep them to yourself. You don't have to say anything if you don't want to. And if you do have any questions, especially towards the end, then Megan will make sure that I understand that you've got a question that you would like to ask, and I will do my very, very, very best to answer them. Right, okay, so we are going to get going. I don't see any reason not to. So I'm going to start sharing my screen again. And here is my PowerPoint. I don't normally teach with a PowerPoint, but on these masterclass evenings, I have to try to get everything, all my ducks in a row. So we're going with the PowerPoint, and you can see that this is the Golden Grades masterclass. Okay, and the idea is that by the end you'll know how to answer every type of question and how to survive your A level. Possibly that's quite a tall order. Well, we'll see. We'll do our best. We'll do our best. Right, so here is the contents of what I am intending to do today. I'm going to put things into perspective a little bit, explain how hard physics is. I'm going to talk to you about the importance of exam technique, because my experience, 25 years now, is that most people who can't score highly in their physics, it's not the physics that's the problem, it's the exam technique. So we're going to go through then some exam techniques. I'm going to take you through the ninja question analysis. I'm going to do that quite quickly because I've got a number of masterclass recordings on my free stuff page of my website, which will show you how to do that. And I'm going to go through explain and describe questions, and you'll see the reason why explain and describe are the most important ones. I'm going to talk about my learning loop, which is all about revision, and I'm going to put that in inverted commas because it's revision, because I don't think you should revise. I know, I'm a teacher saying don't revise. Anyway, I'm going to give you a work plan, which will be specific for your year group and your course, your exam board. And then, because in I don't know, an hour or two, I can't possibly tell you everything that you need to know about A-level physics and exam techniques for A-level physics and get you the grade that you want in your end of year exam. I'm going to talk to you about my tutoring offer. I have got a really quite a good offer, which I'm hoping that some of you will take up. Obviously, I make my living out of selling tutoring, and I do want to help as many of you as I can. So the offer is going to be at the end. So I'm not going to talk to you about the offer first and make you listen to that before you get the good stuff. So we're going to do the physicsy bit first, and then I'll talk to you about your offer. And if you don't want to know about it, you can just leave at that point. No one will mind. Okay. So that is the cunning plan that cannot fail. So the first thing we're going to do is put things in perspective. I don't even know if you can see through my
it's
control.
Not on the screen, Mum.
It's not on the screen. Oh, that's good. So let's put things into perspective. So this is from 2015. So quite a long time ago now, so pre the current course. But this is putting all of the different A-level subjects into order of difficulty. And I don't know if you can see, but on the right hand end, right over there, I'm putting a blue circle around it. There is physics, okay? So it is right up there. It's one of the most difficult A-levels that you can do. Chemistry is not much easier. Biology is not much easier. Further maths is the one on the far right side. So those of you that have chosen to do physics and further maths, oh, okay, that's good. So and there's Latin and critical thinking are considered harder than A-level physics. So yeah, physics is hard. Okay, guys, you've chosen a hard A-level, but on the other hand, it does open a huge number of doors. It's one of those few A-level subjects that is considered, when you've got one, an A-level in physics, you're considered numerate. So physics, maths, further maths, computing, maybe economics, maybe chemistry, but that's it pretty much. So yeah, so it does open doors for you. If you want to go into any sort of engineering, pretty much you have to do physics, and it will allow you to do almost anything. I mean, architecture or archaeology, or honestly almost anything. So physics is really great from that point of view, but it is considered really hard. Okay, so that's putting it in perspective a little bit. Right, we're going to carry on with our putting things in perspective, Lark, and that is this is quite difficult to understand. Obviously you want to look at this left hand column because that's the physics one. I mean, some of you will, oh dear, let's try that again. This left hand column, let's try and draw some reasonably straight lines. Okay, some of you might be doing chemistry and maths and so on. You might be interested in those other subjects as well. Right, now, this is the distribution of A-level grades if you got a GCSE grade A. Right, now, a GCSE grade A is old money, so it's the old grade scoring system. So and a 7 or an 8 is an old grade A. Okay, it's sort of somewhere, it's on that borderline between 7 and 8 is an A. And so if you got a 7 or an 8 at GCSE, you can expect, well, 30% of you will get, well, 29 will get a B. About a quarter will get a C, and about another quarter will get a D or an E or a U. And only 15% will get an A or better. Can you see that if you choose just to do all the normal things that most people do, and you got an A or a 7 or an 8 at GCSE, the chances are you're going to end up with a B or a C. So you have got to make a decision now, pretty much, that you are going to put in the necessary work in order to get your grade up, if what you want to do is to go on to engineering. A B is usually good enough, but an A is better. And not very many people who got a 7 or an 8 at GCSE are going to go on to get an A at A level. So you really need to, right, obviously if you got an 8 or a 9, you're more likely to get an A than if you got a 7. But can you see that really, truly, your natural stomping ground is going to be a B or a C? And so you have to make an effort to improve on that. So this is putting things in perspective, okay? Right, now, moving on, let me clear that box off that I spent so long drawing. Right, so basically, physics is hard, but that doesn't mean that you can't learn how to do it. What advice would you give to somebody who is maybe on the fence about taking tutoring?
I would say definitely do it, because I feel as somebody trying to achieve high grades, it can be a bit almost like embarrassing to try and get tutoring because you think you can do it yourself, but there is a point where you do need to get it. So I was thinking about getting it like early on, but then I had this kind of thing in my mind where I was like, I can do it myself, it's okay. But it's not a bad thing to get help. So yeah.
Okay, so if you could advise yourself, say yourself at this time last year,
yeah,
what would you say to yourself?
I would say just try my hardest to look for the help that I need, because like I think I could have gone to my teacher more as well. And look for help in other people. Yeah. So just definitely just don't be scared to ask for help. basically.
Okay, so advice from one of my students from last year. Yeah, she says, don't be scared to ask for help. Ask for help sooner, it's easier. Okay, right. So we've put things in perspective. We've realised that physics is quite hard. And now what we're going to do is we're going to talk about the importance of exam techniques. Right, I'm going to stop sharing this a minute. No. Right, I have got an exam techniques course, but I'm not going to talk about it. I am going to stop sharing this. I want to talk to you about the importance of exam techniques right now. Most people who come to see me and book a free demo, which is how I do a lot of my getting new students, they tell me that they have worked really hard and that they've done past papers, which most physics teachers will tell you that that's the best way to prepare for an exam. And they've done, they've watched some videos and they've done questions. They've looked on Physics and Maths Tutor or Save My Exams, and they've done a bit of Uplearn, and they've done and some of them even have I've just realised Barney's on my snap. Some of them even have a tutor already, and what they've discovered is that it doesn't seem to matter what they do. It doesn't matter what they do to revise. It doesn't matter what they do, how many past papers they do. It doesn't seem to make any difference to what grade they get in the important tests, the end of year 12 test, or the ones that lots of you have got coming up, where you've got an opportunity to improve on your predicted grades so that you can apply for the university that you want to through UCAS. And you're getting to the point where it's frustrating. Nothing you do seems to make any difference to your grade. Okay, right now, when I talk to these people and I ask them what it is that they've been doing, and then I say, right, okay, what sort of questions do you have most difficulty with? They nearly always tell me that it's the wordy questions. Okay, now this is normal. Okay, most physics students, they are they would much rather deal with numbers than with words. Okay, they're happy with calculate, they're happy with show that, they're happy to a large extent with did use or determine, but they do not like explain. They don't like discuss, they don't like describe, they don't like compare or justify or assess or criticize or any of those other horrible command words. It's calculate, please, calculate. I'd like to do calculations, please. And
use my calculator.
Yeah, and the thing is, right, that if you start asking people, they all say, right, well, I always drop marks on the explain and the describe, those questions. Okay, and it's true, they do. And everybody who is numbers based, they don't like the wordy things, they all seem to have this exact same blind spot, which is that they don't recognize that there are patterns in the words in the exam questions for A-level physics. Okay, I'm going to give you an example. There is a word which is a bit like calculate, but it's not quite the same. It's determine. Okay, so it's determine, I don't know, the speed of the car at t is 2 seconds, right? And I want to know whether or not any of you have ever figured when they use determine as the command word instead of calculate. If you know when they use determine instead of calculate, what conditions, what's special about something, the question, when they use determine rather than calculate in an exam, can you pop it into the chat? When do they use determine and not calculate? Because it's really specific.
I feel like we should have the countdown music.
I've got, yeah, I should, shouldn't I?
Yeah, we've had a few messages.
Ooh.
One of them was, what did Ayat get on her exam? Do you remember? I remember she scored well, I just can't remember what the score was.
I think she got a B in the end. I think she got a B. I'd have to look it up, I'm sorry.
It was a high B though, wasn't it?
I honestly don't remember. I think it was B. I know that she was on a B at the end of year 12, and that she dipped down during the year, and that she wanted, yeah, she was struggling just after Christmas, and she was looking for help.
We've got some answers, my dear.
Oh, answers.
Determine is an approximation.
Determines an approximation. Okay, that's interesting. It's not.
When you don't have a calculator, do determine.
No, it's not that either. No. Determine uses numbers. Definitely.
When they want you to lay out all of your workings. I mean, they always want you to.
They always. You see, these are all really good answers, right? And you've kind of. What's the word? What's the word when you justify things to yourself? You've kind of made up the rules.
I mean, it makes sense.
Yeah, see, the human condition is that you look for patterns, and you've found a pattern, and you've thought, okay, so I've got to show my working, but that's not it. That's not it. As anybody else, it's not.
We've got like use of ratios, assess deeper understanding, determine less problem solving than calculate.
No, it's exactly the same. It means do a calculation and get an answer. So when do they use it, right? Okay, so, and this is what I mean by you've got to do the exam techniques, because if you do enough papers and you bother to look for the patterns in the words, you will discover that they always use determine when you have to get the numbers for your calculation from a graph. They always use it. In other words, determine and graphs go together. In fact, when you read the word determine on a paper, you should go, where's the graph then? Because you've got to use a graph. You might have to draw the gradient on a displacement time graph at t is 2 in order to work out what the speed is at 2 seconds, right? The example question I gave you, or you might have to get the area under the graph, although it's likely to be an estimate, that one, especially if the graph is curved, because you have to count squares. But you might have to get an intercept, or you might have to read values off, especially in year 13, especially if it's a log graph. Okay. Okay, so determine means use the graph. In fact, it's so intimately linked with graphs that they use the word determine when you have to provide the graph. So for example, one of those horrible describe and experiment to show questions, those ones, right? It will say in the stuff that you've got to do, it will say include in your answer how you will determine, I don't know, the constant K for the spring constant of the spring that you're assessing, right? And you've got to then say which graph you're going to plot, force against extension, and K is going to be my gradient. Okay, can you see it? You have to provide the graph, but the word determine means, oh, you've got to use a graph. Okay, so now you know that determine is a code word. Use a graph. That's really useful. Really useful. I mean, very occasionally it's like something which has got a scale on it that's not a graph, like a diagram of a vernier scale or something like that. And sometimes there's a, I don't know, picture with multiple dots from a diffraction pattern, and you have to measure scale, the distance, I don't know, 10 dots or something, and then divide it by 10 or whatever. And so very occasionally it's not a graph, but it is use this image to get the information that you need to do the calculation, and it is a calculation. Okay, so that's quite interesting, isn't it? None of you were aware that determine is like a code word, use a graph. Right, okay, so here's another one, exam techniques. Okay, show that. Why do they sometimes do show that and give you the answer rather than calculate and make you work it out? Can you figure out when they use show that rather than calculate as the command word in a question? Can anybody work it out?
I feel like we should have no need for the countdown. Everyone's to use the next part of the question. You need to use the answer in the next part. You have to show them the way how you get to the answers. When they want to show the method, then you need it for the next part.
Okay, so some of you have got it and some of you have made up an answer again.
When you have to show
You've made it up for yourself. Okay, so when you have to show proof is not it. It's not it.
deriving an expression.
Yeah, you see, that's not it either. That's not it either. If they want you to derive something, they need to say derive. Okay. Sometimes they say show a relationship, but when you use show that in a question rather than calculate, it's because the examiners are lazy. Okay, and it's not that you've got to show you're working, because you have to show you're working with calculate questions too. There's always marks for working, even in a calculate question. So it's not that, even though that's what nearly everybody thinks. So you're in good company if you thought that. Okay, you get show that questions when the answer has to be used in the next bit of the question. And the reason they do it is because, like I say, they're lazy. It's really pragmatic. When you're marking papers, there is a rule that the exam boards all have to apply by, which is that you cannot penalise someone for the same mistake twice. So if you calculated an answer wrong, and then you used that wrong answer correctly in the next bit, you'd get a different answer to the one that was on the mark scheme in the second part. And they wouldn't be allowed to penalise you for getting the second bit wrong because you'd got the first bit wrong, because they will have already penalised you for getting the first bit wrong. And so they have to do a complicated error carried forward. Okay, and that's painful for an examiner, and so they don't like doing it. And so what they do is they do show that. They do a show that question and they give you the answer. Because if they've given you the answer, then even if you got the first bit wrong, you've got no excuse for using the wrong answer, even if you can get it, in the next bit. But what does that tell you about the next bit? It tells you that you've got to use this number that they've given you. So show that questions are kind of like, ooh, this number over here is really important. You're going to be using that in the next bit. Look, here's the number that you need for the next bit. And sometimes it's really, really helpful. Imagine the second part of a calculation question was to work out, I don't know, the speed of I don't know, a car or something. Okay, it's a bit boring, but a speed of a car or something, right? And you realise that you can't do it with SUVAT because the force is changing. Okay, and if the force is changing, F equals ma, remember, the acceleration will be changing, and SUVAT only applies when the acceleration is uniform, in other words, it's constant. So you can't do SUVAT, and you're thinking to yourself, what? How am I supposed to do this? I can't use SUVAT here. It's like rubbish. But the first part of the question was show the kinetic energy of the car was, and you can go, oh, I can do it with energy. Yay! Can you see how useful that is? Exam techniques. Okay, so
we did have a question, which was, but you get ECF marks even if it's not a show that question. I said indeed, because obviously that can happen.
Sorry, say that again.
Don't you get ECF marks, so error carried forward marks, even if it's not a show that question?
Yeah. They do. They don't always do it. So sometimes you do have to use an answer that you've calculated from a calculate question subsequently. Yes. So they don't always do it, but they do it quite frequently, just so that they don't have to do an error carry forward.
Yeah.
Otherwise, they'd have to do 10 on a paper, and that's just, ugh. If you have ever marked A-level papers, you know how tedious that is.
Well, then they've also got to calculate whether or not your answer with the wrong answer from before is correct.
Yeah.
With the wrong answer.
Yeah. It's a pain, which is why they don't do it. Well, not always. Okay, so we've got already now then determine and show that. Okay, and you've got to recognise that there are a load of other things about A-level papers that you've got to get your head round. And if you don't get your head round them, they get in the way of you answering your questions, even if you're really good at physics. Okay, quite often somebody who really should be scoring an A gets a C perhaps, and that's simply because they don't know how to answer explain questions, or they don't know how to answer describe questions, or they can't answer a compare question, or those 6 marker ones, describe an experiment to show, they only ever score 2. Right, those ones, it's ridiculous, because all of you know how to describe an experiment, because all of you done it. You must have all of you got to the point where you've done 6 in class, okay, and if you're at Excel you've got 16 to do, so you should have done 8. Yeah, you see, you should know how to describe an experiment, because you've written up an experiment, you've investigated how to measure, I don't know, G by free fall or something, and you know how to do it, and you've gone through and you've figured out what graph to plot, and you've plotted a graph, and you've got a table of data, and you've put the units in the column headings, and you've figured out which is your independent and your dependent variable. And for some reason people don't put all these things in their answer. They think, oh, it's too much, but it's not, and you've got to put it in. And if you do put it in, it's like 3 marks. It's like, oh, if I put everything in, I'm going to get 6. So when you see a describe an experiment to show in your next major test, you should go, hooray, 3 marks. I can do this. I can score 6 out of 6. Okay. And what you've got to do is you've got to get good at it. Right, now, if I said to you, I've entered you into the London Marathon, what would you do to prepare? Would you watch videos? Would you write notes? Would you study nutrition and how to train?
Flashcards.
Or what would you do? What would you do? What do you think would be the thing that would make the biggest difference?
Running, pretending to be sick.
Prepare to run away. Run, in it, yeah. Give him a star. Give him a star.
A jetpack.
Excellent. Oh, a friend of mine. He does outside broadcasts, and he was at the Great North Run, but he wasn't running. No, he was in a helicopter going round and round relaying signals from. Oh, it was funny.
Watching them all running and going, why would anyone ever do this?
Yeah, absolutely. So can you see that in order to do the marathon, you've got to run? Okay, and get yourself a jetpack, but and if you are going to get good at A-level physics exams, you've got to do A-level physics exams. Right now, this process isn't simple, and lots of you have already discovered that if you just do paper after paper after paper, your grade only very slowly goes up. Now, I am going to come back to what you need to do in addition to doing just paper after paper after paper, because doing paper after paper, believe me, does make a difference. But most of you were missing an essential step. Okay, and we'll come back to it. We will come back to it.
The essential step is a jetpack.
No, it's not. It's not a jetpack.
That's cool. I can do these now.
Where will there be a recording? Yes, there will. It's going.
I've already answered this
Oh,
question,
okay, sorry.
Yeah.
Okay, there's going to be a recording. Right, okay, so, right, we're going to move on. Right, if I just briefly go back to my PowerPoint. Okay, next bit, we are going to do some exam techniques. Now, I did say that I would start with a ninja question analysis. Do you like my ninja? I think he's got pencils and pens and paper and stuff. And yeah, so he's a ninja for exams. Okay, so we are going to start by doing some ninja question analysis. Right now, some of you might, possibly not, but some of you might have already looked at some of my free stuff on my website. Okay, and just in case those of you who are here that haven't, I'll just open my website. just so that you're aware, can you see there's a page called free stuff? Okay, if you click on the free stuff page, well, at the moment, this is the free thing, but if you scroll down, oh, look, past masterclasses. And in these, especially this fields and forces one, I do go through the ninja question analysis that I'm going to go through with you really quickly right now. So if you want more input on ninja question analysis, go and watch the fields and forces. I warn you now, it's 2 hours long. Watch it on speed and a half, and yeah, take on board what you're doing and carry on watching it until you get bored. And then if you are bored, then probably you've seen enough. Okay, so what we're going to do is we are going to do ninja question analysis, and I am going to use I think this AQA paper. Can you see in the top left hand corner? It's an AS paper, paper 2 from June 2018. So what we're going to do is we are going to go through and read the question together, but it's not really reading. Okay, and this is one of the many exam techniques that you've got to get your head around. I'm sure your teachers have said to you, read the question really carefully, and you throw your hands up in the air when you get it wrong, and you say, I did! I read it really carefully, and you didn't. And the reason that you didn't is because, especially if you're really clever, you skim read. Okay, and well, everybody does it. It's a skill. It's a life skill. You practice it every day. I mean, who's read all of the words in any TikTok caption ever? I mean, honestly, well, I mean, honestly, I mean, it's like the only people that ever read anything really properly are people who are studying for exams and people who are, for example, looking for loopholes in contracts and things, right? Honestly,
or people trying to get PhDs.
But honestly, nobody reads anything properly. So you shouldn't think of it as reading. It's not like, you know, it was a dark and stormy night in a novel and you can like kind of skim over it. Well, the weather was bad, right? Kind of thing. You know, what you want is you've got to pay attention to all the words. So the sort of reading that you need to do in an A-level physics exam is much more like trying to find the right line of data in a table of data, or I'm showing my age here, but in an old-fashioned telephone directory, looking for somebody in particular. So you're not reading it exactly. You're working out where the information is that you need. And that's a really good analogy for what reading A-level physics questions is all about. It's not really reading. So this ninja question, I used to call it ninja question reading, but it's not. It's ninja question analysis, is because we've got this problem that is skim reading, and we've got to stop ourselves from doing it. Okay, so we've got to notice everything. That's a big deal. Right, so how do we do it? And one of the things that we do is I don't know if you can see me, I'm very small. I'll go back to showing in a minute. Get yourself one of these highlighter pens. This is really sort of below now, isn't it? It's a yellow one. I don't know if you can see that. It doesn't matter what colour it is. You're not allowed to use these in the answer. Megan will tell you off because she's an invigilator. But you are allowed to use a highlighter pen in the question. And in fact, even the exam boards, they highlight things in bold. So they already do it a little bit. But what I want you to do is get yourself a highlighter pen, and I want you to highlight certain things. And the reason for doing this is because it slows you down. Mm. It slows you down and it makes you look in a different way. Okay, so what we're going to do is we are going to, I'm sharing my screen again. We are going to highlight, well, let's start off by highlighting the command word, just for the very first question. That's what we're going to do. What's the command word? Can you pop it into the chat? Obviously you can't highlight my screen. What's the command word? Yeah, it is calculate. There it is. Calculate the refractive index. there is actually a second part. What's the second part of this command? Have we got any more? Why do you call it ninja question? Because it sounds cool. That is true. I don't know.
Because questions are sneaky and ninjas are sneaky?
Yeah, questions are sneaky and ninjas are sneaky. Oh, what was that? What's the joke about ninjas?
Which one?
What do they wear on their feet?
Oh, yeah.
Sneakers.
Yeah.
Yeah. Anyway, right, there is a second command word in this question. Can anybody tell me what it is? Oh, look, 10 new ones. Oh, dear. Come on. Oh, we've got sig figs. I don't think that sig figs is the command word. I think give is the command word. Give is the command word. Okay, so, but yes, it's about significant figures, isn't it? Okay, right, so far we've got actually 2 command words. Right, now, the next thing that I want you to do isn't going to highlight anything. It is, you've got to tell me, what is the topic of this question? What is the topic, the bit of physics that it's about? Because once you've figured out what the topic is, at that point, then I would want you to open your data sheet to the relevant page that has got the equations for that topic. What have we got? We've got waves. Waves is a very broad topic. Have we got anything that's a little bit... waves. Anything more specific than waves? There we go. We've got refraction. Okay. So yes, it's about refraction. You could have put optics. I mean, it is waves. Don't get me wrong. It's not wrong. Waves is not wrong. It's just that it's a little bit more specific. Refraction. Okay. So now. I don't know if any of you have got your data sheet to hand. Okay. I am going to now make a plea that if you haven't got your data sheet to hand, that you print off about 5 copies of the data sheet and you put one on your desk next to your computer. You put one on your I don't know, the kitchen table if you work there, or in the front of your file when you're which you take to your physics lessons. I want you to put one in your coat pocket so you can read it when you're on the bus. I want you to stick one on the back of the loo door so that you've got something to look at when you're sat on the loo. Okay, because you have got to learn your data sheet, and I don't mean learn the individual equations. I mean you've got to, because you're given those. What you've got to know is you've got to know what every symbol in every equation means, and all of them are used more than once. So in some equations a capital T means period, and in other equations a capital T means temperature, and in other equations a capital T means tension, and in some equations a capital A means activity, radioactive activity. Sometimes a capital A is area, and sometimes a capital A is mass number. Sometimes a C is the speed of light, and sometimes a C is the specific heat capacity, and sometimes it's the speed of a particle. Yeah. And you've got to know which it is from context. Right, does anybody have any of the refraction equations to hand? I think I've seen one. Yeah, we've got one. N is C over V. Okay, so I need to know what's N, what's C, and what's V. Oh, we've got sine C. I'm going to talk about this one in a minute. 1 over N. Okay, that's on some data sheets, not all of them. C is wave speed. Ooh, so is V. Yes. Oh, I like that one. Who said that? N1 sine theta equals N2 sine theta. So it's theta 1 and theta 2. Whoever it was that wrote that, they get gold stars. Okay, that's Snell's law. Okay. So what is n, what is c, and what is v? Now, I've had some people have said c is the speed of light. So this is 3 times 10 to the 8 meters per second. Good. Okay. What's v then? V is the speed in the medium. Give Adam a star. Good.
Specifically in the medium as well. That's good.
Speed in the medium. And in fact, can you see that we've got two different mediums? We've got glass A and glass B. Okay. So right. So what's N? N is refractive index. Well done. Okay.
Everyone's doing great. I'm liking this.
Okay, so N1 is C over V1, okay, the speed in V1, sorry, the speed in material 1 is V1, and N1 is refractive index, okay, so here we're going to have A and B, aren't we? Right now, what we have, right now, all we've done so far is we've highlighted our command words, and we've found the equations, right, that's all we've done so far. Okay, the next thing I want you to do is I want you to highlight any numbers. Okay, so I'm going to go through and I'm going to highlight numbers. I've got that number, and I've got that number, and I've got that number, and I've got that number. Have I got any other numbers? Oh, we've got 3 marks, I suppose. And we've got figure 9. Don't think that really counts.
Mazin would like to point out that the speed is 2.998 times 10 to the 8 meters per second in the question.
Yeah, it is. It's not 3 times 10 to the 8. You're quite right.
I mean, it's real close.
It is real close. Yeah. Okay, 2 thousandths out. But yeah. Okay, so can you see so far? Let me write down my little list of things that I've done. Okay, so far I've highlighted the command word or words. Okay, we've found the equations. Okay, we have highlighted the numbers. Right, now the next thing that I want you to do is I want you, please, to highlight any numbers that aren't numbers. So these are words which give you quantities, but they're not numbers. So things like at rest or stationary, or here we've got partially reflected. Okay, we've got a refractive index name. Okay, we've got 2, in fact, NA and NB. Okay, we've got a word that says number of significant figures. That's a number, right? It's not a number, but it's words that mean a number. Okay, and we've got the speed of light. That's kind of a number as well, isn't it? Okay, can you see? And sometimes these words, they kind of slide under the radar. They can be things like, ooh, who said less? Ooh. Good. Ooh, that was a sneaky under the radar one, Taz. Well done. Okay, so sometimes it's things like the words each second, just thrown away, added at the end of a little sentence. Yeah. Sometimes it's the bricks were released at the same time. Sometimes it's proportional or half or double. Okay, so there are and the word recoils. Okay, that tells you the direction of a momentum vector. Okay, so these words that are numbers, that hide numbers, you should highlight those as well, because it makes you read them. Right, now, the next thing you really ought to notice is how many marks, which we've already highlighted actually, which is 3 marks. Okay, now, how many marks a question is tells you whether it's really hard. If it was a 5, right, AQA have the last papers, there were at least 2 and possibly 3 questions, calculate questions that were 5 marks.
Ew, no.
Yeah, nasty. And so and you can tell that if a calculate question's 5 marks, that's hard.
You could get an error carried forward in that question.
Yeah, within it. Yeah. Anyway, so but 3 marks for calculate. Well, okay, right. All A-level questions are 2 equations, pretty much. Sometimes it's the same equation twice, but pretty much all calculate A-level questions are 2 equations. If it's 3 marks, can you see that here the 3rd mark is for the number of significant figures? So it's 2 for the calculate and 1 for the significant figures, which gives us 3 altogether. Okay, can you see how that works? So now if it was a 4 mark calculate or a 3 mark without the significant figures, you'd know that you not only have to use 2 equations, but you might have to use the 3rd one, or maybe you have to use 2 equations twice or something. Okay, can you see that you can judge how much work you've got to do in order to score those? So the number of marks is actually really significant. Right, now we've done all of our highlighting now. So now what we're going to do is we are going to go through and we are going to read this for meaning. Okay, so this is the first time we've actually sat down and thought about what all these words mean. Okay, can you see this is not regular reading? Okay, so figure 9 shows an incident ray of light. Which is the incident ray? Okay, so it's there. Oops. There is my incident ray. Okay, it's coming in from the left and it's partially reflected. So some of it's reflected. Right, now I am going to put into my diagram, because this is what you should do when you're reading for meaning. You should draw a diagram. Now we've got one. So what we're going to do is we're going to add to it. Okay, and if you haven't got a diagram, then you draw a diagram, I don't know, of an aeroplane with a man jumping out of it, or of parallel plates with an electron between it, or something, right? Whatever it is, you draw it, right? Here, we've got a diagram. So what we're going to do is we're going to add to it. Right, now, I'm going to add to this diagram I want a dotted line. I don't think I can do one. Anyway, okay, I'm going to add to this diagram a normal. Oh, that's rubbish, but anyway, there we go. It's meant to be at 90 degrees, okay? So so this angle here is 90. Right, now, why have I put in a normal? It doesn't say anything about normal, but I know, because I've done my physics, that the angle of incidence and the angle of reflection, and in fact the angle of refraction, are all measured between the ray and the normal. Okay, so I'm going to need a normal in there. Okay, so in the normal's what it says, it's at right angles to the surface. Okay, and if it's a curved surface, then it's right angles to the tangent to the surface. Okay, so we've got an angle of incidence, and the angle of incidence and the angle of reflection are the same, and the angle of refraction I'm going to call R. Right, now, okay, so all I've done is I've recognized that this is a ray diagram, and I've seen my incident ray, and I've thought, oh, I better put in a normal. Okay, so and it says the refractive index of glass A is 1.461, so we've got that number. And then it says the speed of light in glass B is that much less than the speed of light in glass A. Okay, and we've got to work out what the refractive index is of glass B. So how are we going to do this then? So at this point, we have to start doing our solving our problem.
We have a potential solve part of it.
Yeah, so Path is absolutely right. We are going to find the speed for the light in A. And we're going to use this equation because it's right in front of us, because we went and opened our data sheet and saw it right there. Okay, so we're going to rearrange it. We're going to go VA is equal to C over NA. Can you see what we're doing? Okay, so we're going to do that, and we're going to get VA. Why are we getting VA? We use the percentage to find speed b, and then we can work backwards with the same equation. See, same equation twice, it so often happens, to get the refractive index of b. Absolutely. So we're going to get VA. So we're going to do this. So this is 2.998 times 10 to the 8, and we're going to divide it by 1.461. Who can tell me what the speed of light in material A is?
2.998 times 10 to the minimum, and then
Yeah, that's the right sum.
what's the answer?
Yeah, but well, Venise wants to go ahead and then multiply it, well, work out what 3.252% less than that is. But let's find the speed of A first. So what does that say? 2.52 times 10 to the... No, that's not right.
No.
I don't understand that. Oh, it's turned it into a phone number or something.
Oh no, I think that's an actual answer. We just need to...
2.
Yeah. 2. So it's 2.05 times 10 to the 8. Thank you, Hayley.
2.05 times 10 to the 8.
I wasn't looking at my keyboard when I typed it. You were looking at the calculator going, ah!
Everybody's hurrying because they want to be first. Okay, so we've got the speed of light right now. Is 3 significant figures enough? No. Why not? Why not?
Someone said 4.
Yeah, we need at least 4. Can you see? Because we've got 4 for the refractive index of glass A, and this question has asked us about significant figures. So we need at least 4, and in fact, this is a kind of an in-between measurement. So we really ought to give 5 in between. So what is it actually? It's not 2.05. What is it actually? I want 5 significant figures, please.
So they put 2. I'm sorry, I shouldn't answer that. You're not actually asking me.
I wasn't actually asking you, no, Megan. I really wasn't.
2.0520 times 10 to the 8 from Joe. 2.0520 from Nigel.
Okay,
Ooh,
right, so like
got
this.
a real question is, can we use inverse proportions? We know the index and speed are inversely related, therefore we can divide index of A by 0.97.
Yeah, you can. Yeah, you can. So well done, Akash. No, there's an A star. That's an A star student. Right, okay. So
using advanced maths techniques.
Using advanced math techniques is ratios. Ratios comes up a lot. Okay. So what we've done is we've worked out an in-between value. Okay. Now, can you see the problems with working out in-between values here, especially when they're asking about significant figures? We do need to be really quite careful, don't we? Okay, so we've now worked out VA. We've got to work out 3.252% less than that. So it's 2.0520 times 10 to the 8 times, and then it's 1 minus 0.00, no.
Human error, counting. Counting decimals.
3252, okay? And you get a new value for which will be VB.
Oh, we've got an answer already.
Okay, and VB, we're going to do C divided by that to give our refractive index. So this is the sum. If I do C on the top, it's 3 times 10 to the 8, and that will now give me not VB but refractive index of B. And actually, of course, it isn't 3, it's 2.998. Okay, so Hajara.
I'm answering it.
Okay, good. By the sig figs you were given in the question. Yeah, absolutely. Okay, so has anybody got an answer for the refractive index that we need to put in? I get 1.510 is what I get. Okay, I have given my answer to the correct number of significant figures for this question. So, and you are answering with lots and lots of significant figures because I've encouraged you to do that in the chat, but you've got to give your answer to an appropriate number of significant figures. And because every number in this question is 4 significant figures that they've given you, you have to give your answer to 4 significant figures. And that's how you know what the appropriate number of significant figures is. Okay. Okay. Has this kind of helped you a little bit with your ninja question reading? So the steps are: find your command word, find your equations, highlight all the numbers. I haven't written all of the steps down. I'm getting rid of all of this now. Highlight all of the numbers. You need to highlight sort of words that mean numbers. You need to then read for meaning. And as you are reading for meaning, you draw a diagram, or you add to the diagram that's there. Okay, right, now obviously we could go on and do the next bit, but we're not going to. I just wanted to use this to illustrate this ninja question analysis technique. Okay, so this is how you read a question. It's not really reading, so that you don't miss stuff. Okay, it's not really about problem solving. That's a separate exam technique, and it's not really about, I mean, it has been about significant figures here, but yeah. Okay, right.
We have a question about figures.
Oh, more significant figures. Okay, otherwise, do we give our answer in the lowest number of significant figures used by the numbers in the question? Right, Path. I would recommend that unless they ask you to give your answer to an appropriate number of significant figures, or it's a practical physics question, in which case you need to pay close attention to it, that you always give your answers to 3 significant figures, just as a routine thing. There needs to be a special situation where you wouldn't give it to 3. So you wouldn't give percentage uncertainty to 3. You probably would only give it to 1, unless it's less than 1, in which case you'd probably use 2. And so on. I mean, the significant figures thing, this is why all of you find this so hard, is because it's not really very consistent. So most of the time, give your answers to 3. If it's a practical physics question, then you need to potentially think a little bit harder about it. Okay. Right, okay, so that was ninja question analysis. Right, now, the next thing that I wanted to talk to you about, when I go back to my PowerPoint, I can't bother to actually start it. Maybe I will. I want to show you this, okay? So this is all about how often different command words appear. And you can see, this is very anecdotal. I've just I think it was just 1 EdXL paper, 1 AQA and 1 OCRA paper. And all I did was I went through and I counted how many explain questions, how many calculate questions, how many state questions, etc., etc. And I didn't weight them. So explain questions tend to be 2 or 3, sometimes more. Calculate often 2, 3, sometimes more. State is nearly only ever 1. So can you see they're not weighted at all? It was just how many times did the command word appear on the paper. And you can see that actually if what you do is you combine together all the different command words that make you do sums, okay? So calculate and determine and show that, and it's not there. There's another one which, oh yeah, it's there, deduce, right? those four together make you do sums. So those four together are all really sort of derivatives of calculate. And if you allow for all four of those, then calculate is the single most common command on an A-level physics paper. Well, that's a surprise. Not. Okay, so, which is what you'd expect, wouldn't you? So calculate's right up there, which is good.
Yay!
Because lots of you are good at calculate.
I get to use my equipment.
Okay, now can you see though that of the remaining command words, the ones that come up most often are explain, state and describe. Which means that if you can do calculate and you can do explain and you can do state and you can do describe, pretty much you've got maybe 80% of the command words cracked, sussed, sorted for your A-level physics exam. So what we're going to do, I mean, calculate, hopefully, most of you are all right with. State, I'm going to do this really quickly, is say the number, usually, or the word, okay? Usually you don't have to do any sums to find it. It will either be in the question, or it will be on your data sheet, or it will be obvious in some other way. Okay, so state doesn't require any calculation. So so that is, it's basically find the right number. Okay.
It could be a law as well.
Yeah, it could be the law. So state, I don't know, Newton's second law or something. Yeah. Okay. So so state is usually relatively straightforward. Okay. Explain and describe, however, those are the bane of almost every A-level physics person's experience. Okay.
Don't like it.
They don't like it.
If I wanted to write an essay, I would have done biology.
Okay, and this refers back to I saw a question in the chat where somebody was saying, well, if you practice A-level physics exams, why is it that you don't get better? Surely practicing A-level physics exams will make you better. Okay, and this comes back to them because when you do your papers, your practice papers, you do a question and you don't get full marks on it. What everybody does, and this is the problem, what everybody does is they think when they haven't got full marks on a question, and it's nearly always an explain or a describe, they think that the problem is that they didn't understand the physics. And they go away and they revise that bit of physics. And it wasn't the problem. And so what they're doing is they're filling in the wrong hole in their knowledge. And just this, if you don't take anything else away from this masterclass, apart from this one thing, please, please, please be aware that probably when you can't do an A-level physics question, it's the chances are that the reason that you're not scoring full marks is because you don't understand the exam techniques and not because you don't understand the physics. And yet everybody goes away and they revise the physics. And they say, oh, well, I can't practice exam questions yet because my physics knowledge isn't sound enough. And actually their physics knowledge is really good. And they and what they need is to have a go at some questions and figure out the exam technique knowledge that they've not got. And that's what's missing.
It's understanding how to answer the questions.
Yeah, how to answer the questions.
Not the questions.
Exactly that. So you guys have got to recognise several things. First of all, you've got a wall of physics knowledge, right? Which is what you're creating and filling in when you do lessons and questions in class and stuff that your teachers are busily constructing with you. Okay, and you do absolutely have to learn all the concepts in the first place. Don't get me wrong. What you're doing in class pretty much every day that you're in school is absolutely the right thing. And your teachers have got to teach you the physics knowledge. You can't do A-level physics questions without knowing the physics, right? So that is essential. That's that wall of physics knowledge. But on top of that, there is a wall of exam technique knowledge that some of you have got absolutely no idea is there, and that you've no idea how big the gaping holes are in your exam technique knowledge. And if you can fill in some of those exam technique holes, you will find your grade going up really quickly. Okay, I'm going to tell you...
Without having to revise the physics.
Yeah, without having to revise the physics. Okay, so I'm going to tell you a story about Michaela. Okay, Michaela, she didn't ever do any regular tutoring with me. She did my Easter intensive course, and the Easter intensive course was 7 days. That was it. 7 days. Yes, it was intensive. Yes, we did lots. We did all what I call the pain points of physics. So all the bits that everybody struggles with, which in year 13 are going to be gravitational potential. It's going to be electromagnetic induction. It's going to be
Particles.
No. Most people are right with particles. Waves and potential dividers from year 12. Anyway,
particles and waves are the same thing.
Oh, right, yeah. You are talking to a physicist. Anyway, right, okay. So, but I can't remember what I was saying now. I got interrupted.
The pain points.
Pain points, yeah. So, yes, Easter course, right, Michaela. Right, so we did all the pain points, right? So we did quite a lot of physics, but it wasn't anything like all of the course, because there's no way in 7 days you can teach a whole of A-level physics. So I just did the bits that most people struggle with, you know, I don't know, capacitors, discharge and stuff. Right, okay, so now the main thrust of the 7 days was exam techniques, and we went through the ninja question reading, we went through all the command word scaffolds, and we're going to go through a couple now. We went through problem solving and what to do when you don't know what to do. We went through how to revise. We went through how to what you should be doing actually in your exam. I call this a game plan. Okay, so we focused in on these exam techniques, what all the different words mean, how you can read your exam paper, the importance of the structure of the paper, and right, masses and masses of exam techniques, 7 days of it. Okay, and she just did 7 days, and then she did 2 more weeks after that of practice papers where she was putting into practice the things that she'd learned in the Easter course. And she, before the course, was on a B, and after 3 weeks, 1 week of actual intensive, 2 weeks of practice, she'd gone up to an A star. 3 weeks to go up 2 grades. 3 weeks. It's possible. If your problem is exam technique, and I can probably pretty much guarantee that 80% of your problem is exam techniques, you can improve your grade in 3 weeks. She worked hard and she is very bright. She got an A star in her exam. So it is possible. So what we're going to do is we are going to talk about the scaffolds for the 2 really, really common command words that are not calculate. Okay, so explain and describe. Okay, right, now the next thing I'm going to say before we do the scaffold is that if you explain when you've been asked to describe, and if you describe when you've been asked to explain, you won't score marks. And I want you, I know all of you think of exam papers as question papers, which of course they are, but I want you to now start thinking of them as instructions on what to write. Because if you do explain when you've been asked to explain, and you do describe when you've been asked to describe, lo and behold, what you write ends up being what's on the mark scheme. There is a 1-to-1 relationship between what they've told you to put and what's on the mark scheme. I promise you, it's much simpler than you think it is. You've got this idea that the words, because you're numbers people, the words are like a black box. But when I was your age, a bit younger, my English teacher said to me, I never did A-level English, it was GCSE. We studied Macbeth, right? And she said to me, she said, Alison, you do realise that Shakespeare writes in English, don't you? And I went, really? Really? I'm going to say the same thing to you. Exam papers are written in English. So long as you understand what those words actually require you to do, it's easy. So what we're going to do is we're going to suss the command word structure for explain and for describe. And suddenly your marks are going to start going up for explain and describe questions, because you're filling in the holes in your exam technique wall of knowledge, which until now you didn't even realize you needed to do. Okay, so we've done the AQA one then, which was ninja questions, right? So let's get rid of that a minute. Come on. No, thank you.
My screen had been so dark, and then that came on and it blinded me for a second.
I'm so sorry. I'm so sorry. Right,
No, it's fine.
let's get rid of that.
Just
Are we gonna get rid of-
if anyone was looking at me and that just saw me go, ah.
And we're going to get rid of that. Okay, I just thought I would show you. There is the answer. Can you see that? It's very small.
Teeny tiny.
Teeny tiny. We got the right answer.
Yay!
To the correct number of significant figures. Just thought I'd mention that. And can you see that here they've allowed for this ratio thing? Who was it that said the ratio thing?
Oh, give me 1 second, give me 1 second.
Anyway, well done for the ratio thing.
Inverse proportions, a cash.
Yeah, a cash. Well done. Okay, so what we're going to do now is we are going to look at this question. Oh, actually, maybe not. I looked at that and saw describe. It's actually describe and explain. So I'm going to move on. Let's see if we've got another describe. That's a show that. Calculate. State. Calculate. Determine. Look, there's the graph. Where was the graph? There's the graph. Right, it's not that one.
Where's the graph?
Where's the graph? Suggest. Oh, that's horrible. Horrible command word.
Raihan has said,
Oh,
I remember doing this paper.
We got explain, determine, determine. Have we got another describe? Explain.
I think that if you remember doing this paper, then this might help you see how the exam techniques and ninja question analysis might help you.
Bother. Right, okay. Okay, this is really annoying. Right, I'm going to choose a different paper. I don't want AQA because we already used AQA.
Use this paper anymore.
I'm going to, because I want to do an OCR-A one and I want to do an EdExcel one. And so, right, it was 2018. Let's go for the paper one.
By the way, whilst Alison is doing this, this is on her specific, the Fortitude Tutoring Google Drive. We have literally thousands upon thousands of past papers.
Yeah, thousands.
Including legacy papers.
I mean, at least 3,000 and probably more like 7.
Yeah.
Right, so we're looking for, this is all multiple choice, so we're not going to be doing multiple choice. And we're looking for a describe command word, that's what. And you can see that I'm not, there we go, that'll do. We'll have that one. Okay, right at the very top.
And we've got a little trolley on a ramp.
Yeah, but that's part B. That's part B. Right. Okay. So, ninja question reading. What's the command word? Oh, do you think it might be describe? Okay, there it is. Woo. Okay, describe. Okay, ninja question reading. Any numbers? Well, we've got 2 marks, haven't we? What is this question about? What's the topic?
Who knows? We need to scroll way down. Ooh,
Mech'll do. Yep, mechanics, definitely. Okay, so it says a trolley. Ooh, I mean, I haven't got any other number. Oh, I have. Oh, look, sort of. Look, we've got a final velocity v. Okay, it's released from rest. There we go. At the top of the ramp. Travels to the bottom of the ramp. Constant acceleration. That means we can use that. See, loads of information. We got bottom of the
I got it, Karen.
sorry. My husband's come home. So we got the bottom of the ramp. Can you see? We've got loads and loads of a long ramp. Okay, right. What else? Anything else?
We had, for the topic, we had inclined planes
Inclined
and
planes.
mechanics, but practical use.
Practical use for mechanics. Okay, right. So we've done all that. I hope you've opened up your data sheet at mechanics equations rather, not questions. And what we're going to do now is we're going to read it for meaning. So we've got a trolley. It's placed on a long ramp. Well, we've got a picture, haven't we? Here is our picture of what's going on.
A diagram.
And it says it's released from rest at the top of the ramp. Okay, well, let's assume that X is the top. Okay, and it travels to the bottom of the ramp with constant acceleration. So we're going to assume that Y is the bottom. Okay, and then it says describe how a meter rule and a stopwatch. A meter rule. And a stopwatch can be used to determine the final velocity, and that's in bold, final velocity of the trolley at the bottom of the ramp. Okay, how can we do this? We've got to determine, there's no graph here, or is there? It says describe how we can determine.
We've got, not sure that SUVAT use, you'll have t of distance, initial v is 0 as it is left from rest, and the
okay, right, I am going to say, look, we are dealing with command words here. What does describe mean in English? What does describe mean?
I love how this has turned into an English language class. Tell what it is.
Tell what it is, sort of. It's what it looks like. It's what it looks like. Okay.
Looks like a trolley to me.
Right. Describe me. What would you say? I'm a fat, old, white woman. Well, I am. I would. I'm a fat old white woman, right? I've got my hair up in a bun.
Funny.
Funny.
Gina says funny.
Funny, thank you. Okay, but can you see it's not calculate using SUVAT? Is it? That is not the command. The command is to describe how you're going to use, and that's why I drew it, a meter rule and a stopwatch. You are not going to calculate it with SUVAT. How can you determine the final velocity? What can you do?
You have to tell the process.
You have to tell the process. Well done, Maria. Absolutely. Okay, so this is this is describe now. Describe. This is the command word structure. So this is what you have to do when you get the command word describe. You have to say what you see, or what you would see with your mind's eye if you can't see things like electrons jumping up and down inside atoms or something, right? But here, this is what would you actually do with your ruler and your stopwatch. They've told you to describe how you're going to use a ruler and a stopwatch to figure out what the final velocity is. What can you do? I mean, you're absolutely right. SUVAT would be easy, but that's not what you've been asked. Can you see? This is what I mean by the exam paper is a list of instructions to you on what to write. So you have to tell the process. Absolutely. You have to tell the process. Okay. So how can you, right, can you see that at the top we've got, I mean, if we did SUVAT, right? What would we need in order to get our final velocity? Can you see that our starting velocity is 0? Can we get a distance? Ooh, I think we might have a distance measuring tool.
Well, we've got time. Yes, measure the distance with the ruler at the eye level.
Ooh, okay. So we've got, right, so we can measure the length of the ramp, can't we? So we can measure that, okay. Do we know A? Not really. I mean, we could pretend we know A, but we'd have to work it out. We'd have to take components. We'd have to know what the angle is of the ramp and stuff.
Yeah, and it looks
See,
like
we don't
know the angle.
we don't really know A. We want to find, so I'm going to put a cross through that. We want to find V, so that's our unknown. So, but we can measure T. Ooh, we can measure, we've got a T measuring instrument. It's called a stopwatch. Right, so we can measure what time? What time can we measure? We've measured the length from the top to the bottom of the ramp.
Total time of travel.
Total time of travel. Good. Okay, so our total time of travel is the time it takes for the trolley to go from the top to the bottom. Okay, so this is the time from the top to the bottom. Right, now, we, however, cannot use speed is distance over time, can we? Why can't we use speed as distance over time? Oh yeah, path. Well done. Yes, yes, yes. Yeah, because it's accelerating. Well done, Bunny. Right, okay, so we can't just use speed as distance over time. We have to basically work out what the average speed is, right? So the average speed is our starting speed plus our final speed divided by 2, and then we can work that out, multiply that by t, and that will give us an equation which we can use to get v. Oh, look, it's one of the Suvat equations, okay? So it is sort of Suvat, but can you see, you need, right, now, we've got to describe how we're going to determine this. Right, I'm going to rearrange this. Maybe I'm not. No, do you know what? I'm not. Okay, let me suggest something to you. Okay, if I write this, what does that remind anyone of? A graph. Okay, what sort of graph? Straight line graph. So can you see that you could measure the ramp length S and the time it takes to go from top to bottom, and you would get, one assumes that if you don't push it or anything at the top of the ramp, a straight line through the origin. Okay, and the gradient of that line would be u plus v over 2. Right, now u is 0, so basically it would be v over 2. Okay. Okay, so all you have to do is double the gradient to get, right, now, right, I'm just gonna point out something to you. There's a word there. What does that word mean?
Graph.
Graph. It means graph.
We've got all caps. I love it.
Graph. Okay,
Yes,
so
dear.
now, can you see that this is describe? Okay, so this is the command word describe. It means say what you see, but that's not enough. It's say everything that you see. So you've got to describe how you're going to determine the velocity, the final velocity. So what you're going to do is you're going to measure a distance on the ramp. You're going to time how long it takes for the trolley to go from one end to the other. And you're going to plot S against T. And twice the gradient will be your final velocity. Can you see that is now describe how to use a meter rule and a stopwatch to determine the final velocity of the trolley?
So you'd show the y equals mx against the
Right now,
equation
well, you don't have to. I mean,
to justify what is on.
We are right. Really, technically, okay. Right. The v, of course, is this is only the final velocity at the bottom of the ramp will depend on s, won't it? So it's not a straight line, is it?
Well,
it's not a straight line because v is not a constant.
Yeah,
it's not a straight line. So nobody corrected me? So you can't do this. You can't do this because it's not going to give you a straight line.
No, it's going to go.
It's not going to give you a straight line. But what you could do, I mean, the gradient is right. You do have to double it, right? So it's not a straight line because v is not constant, right? So I'm going to cut up, right? I'm going to get rid of that. So misleading you. I'm very, very sorry about this because I've got my head right. So it's going to look something like that. And what you've got to do is you've got to find, this is the length of the ramp, right? I'm going to call it L. And then you'd have to draw the tangent at that point, and that would be double to give you your V. That's now correct. Okay, so but can you see that this is not it's say what you see is not enough. It's say everything that you see. Can you see? It's really easy to get it wrong. Okay.
We've got acceleration is constant, so VT graph is straight. Question mark?
Yeah, the VT graph would be straight. Yes.
But this is an ST graph.
Yeah, this is an ST graph.
And
right, the graph would be curved because it's accelerating. Velocity is not constant, huh?
Yeah, so it starts off slower and it gets faster as it goes down the ramp. So it goes.
Oh, okay, yeah. Right, okay. So now, can you see then that describe? I mean, you can tell that I didn't prepare this, can't you? Describe is say everything that you see. Right now, this is question 21 from the. Right, hang on. Get rid of this. Clear all the drawings.
Oh, we've got, why would the gradient be v over 2?
Because of the equation, it's u plus v over 2. It's the average speed is what you'd get. When you do total distance divided by total time, you get the average speed. But u is 0, so it ends up being v over 2 because it's u plus v all over 2, but u is 0, so it ends up being v over 2. Does that make sense?
So it's basically v minus nothing.
Would you lose marks then for just doing it algebraically? Maybe. Let's have a look at the mark scheme. Okay, so it was breadth, and it was question 21, wasn't it? Oh my goodness, it's very small.
Teeny tiny.
There it is. Okay, so distance, displacement, length measured using the meter rule, and time measured using the stopwatch, and then S is half. So if you didn't say the first bit, you'd only get 1 out of 2. Okay.
We've got an okay.
Got an okay, excellent. Right, so that was a describe, and we've been going an hour and a half already, and I want to move on. So
what I will say, Path, is that if we also look at the examiner's notes on it, you can see where people would have messed up or would have, done something not necessarily correct. and where most people would have got it wrong.
Yeah, examiners' reports are really, really cool. Right, now, this one's a describe. Oh, I thought I'd got an explain. Right, we're gonna look for an explain.
Do a Control F and type explain.
Yeah, could do. Let's deduce. Oh, there's an explain. That's a 5-mark explain. Oh, that's a beefy one. Right, okay.
Do it.
We're gonna do it. Can
you zoom in a little bit here?
Yeah. We're gonna zoom in.
Because that's quite teeny tiny writing.
Quite teeny tiny. Okay, so this last paper we're going to have a look at is an Edexcel one, and we're going to look at the explain command word, and this is the other big one. Okay, so explain means key fact, consequence. That's the structure. Now, if it's a 3-mark explain, it's 2 key facts, 2 consequences. Okay, if it's a or 2 consequences. If it's a 3, then it's 2 of one and 1 of the other. If it's 4, then it might be 2 and 2. This one's 5.
3 and 2.
Yeah, might be 3. It's probably 3 and 2. Might be 2 and 3. I mean, it might be 1 and 4, but right. Okay, so but the point is the structure is key fact consequence. Okay, so key fact, and then that's worth, every key fact is worth a mark, and every consequence is worth a mark. Okay, and often in physics a key fact can be an equation. Okay, so that's important. And so for example, explain why the ball accelerates. Okay, and it's a 2-mark explain. So you say, well, F equals ma, and F is not 0, so A is not 0. Okay, so that is a really basic explain. But explain then is key fact consequence, and it might be more than 1 key fact. The one that I always use when I do free demos is the one that's explain why your bedroom carpet is wet, and you go, well, Mum, key fact, I had a glass of water on my bedside table, and I hope we don't have anybody called Derek, and Derek the cat got in my room. 2 key facts, right? You can see where I'm going with this. And Derek did what all cats do and knocked the water off, and now my bedroom carpet's wet. Consequence. Okay, so can you see the structure? And it's the same for every explain. Okay, so our starting key fact has got to be the key fact upon which our explanation hangs. So it doesn't have to be a glass of water on the bedside table. It might be, well, there's a hole in the roof, right? And second key fact, it rained, right? So we've got to get the right key fact. So let's have a little look at this explain. We've got in 1925, Frank and Hertz were awarded a Nobel Prize in Physics for their discovery of the laws governing the impact of an electron on an atom. Okay, so let's draw what's going on. Okay, so here is my atom. It's got positive nucleus, and then there's electrons around the edges. So here are some electrons, right? And an impact of an electron. So here comes my electron, and it's coming in, and it's going to hit another electron, isn't it? In one of their experiments, a beam of high-speed electrons is fired through mercury vapor. So this is mercury. Okay, an electron in the beam collides with a mercury atom. Oh, look, there it is. I've drawn it, which becomes excited. Oh, what does that mean? What does that mean? That means that my electron moves up to the next level. So now it's sitting there, and it's in a, oh, I am excited state, okay? And those excited electrons, they have a tendency to just collapse back down into the lower energy levels. And in the process of doing that, what happens? In the process of doing that, what happens is that when the electron falls back down, it gives off light. And the energy difference between that level and that level, E1 minus E2, equals HF. which is the energy of the photon that comes out. Okay, right, so it then says the atom returns to its initial state by emitting electromagnetic radiation of a single frequency. That's a number. That's a number. Okay, and then what we've got to do is we've got to explain why excited atoms only emit certain frequencies. We've got to explain. Why do we only get certain frequencies? What is the key fact here? Can anybody give me the key fact upon which this explanation is going to hang? Why do we only get certain frequencies? What is key?
Yeah, you're gonna have to scroll down a lot. Oh,
Oh, Isla! Cooking with gas, girl! Cooking with gas! Yes, 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 yes! We've got discrete energy levels. Right, now, can you see that word discrete? They're not vague, they're not woolly, they're not all over the place, they can't change their levels, they're fixed, they're discrete. You get that one and you get the one inside it, but you don't get anything in between, they're discrete. Can you see that now, that key fact, absolutely, without any shadow of a doubt, is gonna be one of the marks on the mark scheme. Can you see suddenly from being really vague about, oh, how am I going to do this? It's like, well, that's got to go in. That's my key fact. So that's definitely going to be on the mark scheme. We're going to score that mark. Right. Okay. So we're going to say that electron energy levels are discrete. Energy levels are discrete. Okay, so I've done one. I'm not going to be able to fit this in because I'm a messy pup and I get it all over the place. But that's our key fact. Okay, so do we have any other key facts? Okay. Is there another key fact, or have we got a consequence of this?
let them try.
If we'd done our ninja question reading properly, we'd have some equations right in front of us. Which equations might be in there?
Oh, we've got a therefore.
Ooh, when an electron gets excited, it increases by a specific amount. When an electron de-excites, it releases a specific frequency correlating to the energy difference of the two energy levels.
Yes.
Okay, so can you see that is definitely a consequence? Okay, so right, where does the frequencies come in? So we've got specific frequency. Oh, we've got an equation. Yeah. Okay. An equation, E is equal to HF. That is a key fact. Right. But it's not E is HF. What is it? It's this one. Can you see it's the energy of one electron energy level minus the energy of the lower one? It's the difference in the energy levels.
So our key fact is two equations.
Well,
smushed.
Yeah, kind of E1 minus E2. I'm just going to go like that, HF. Right, can you see that is definitely one of our 5 marks? Okay, can you see that suddenly it's no longer vague? We've got to say about discrete energy levels. We've got to say about the energy of a photon. Right? What else do we need? We've got to explain why excited atoms only emit certain frequencies. So this is when we actually start using our words, and we need to say that an electron, when it falls from a higher energy level to a lower energy level, gives off a very specific frequency. That's the energy of which is equal to that difference, okay? And you've got a whole range of different energy levels. So you could draw a little, you know, those ladder diagrams. So my atom on the right hand side is a circle. But if I was to draw one of these ladder diagrams, do you know what I mean by that? Where we've got, this is the ground state, and then we've got more energy levels up.
Yeah, I remember this.
Yeah? One
Is
of
this
those
in
ladder.
chemistry as well?
Yeah, it's in chemistry as well. Okay, so if you've got an electron, say, sat there, then it might do that, or it might do that, or it might do... Can you see how much easier it is to explain what's going on if you draw a little diagram? Okay, and once it's got to there, it might do that, and it might do that, and it might do that, and once it's got to there, it might do that, and it might do that. Can you see? You can work out all of the different ones, right? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 if you've got 5 energy levels. It's 6 if you've got 4, and 3 if you've got 3. Yeah, so you can work it out. So each wavelength, each different energy jump gives you a specific frequency. Can you see that you've got to explain that? You have to say that. These discrete energy levels, that's a key fact. Consequence of having discrete energy levels is you get very specific energy jumps. An electron goes from one higher to one lower. And you've got to explain that. You've got to say that. That's the consequence of having the discrete energy levels. Can you see what you've got to put in here? Now, I haven't actually written the words, and we are running out of time because I want to move on. So I'm going to open the mark scheme for this. Okay. And in the indicative content, I'm going to... oh no, that's band. That was the elastic band thing. What number was it? Oh, who? 12. Number 12.
There it is.
There it is. Okay. So we've got to do, can you see? Electrons exist in discrete energy levels. Oh wow, what a surprise. That was our key fact. Oh, it's there. It's there. It's got to be there. Okay. So the electrons, they move back down to a lower energy level, or they move down from a higher energy level, whichever, it's the same thing. Can you see? That's a second key fact. That was what Path wrote, I think, yeah? Was it Path? Somebody did. And then photons are emitted, right? Mm-hmm. And can you see we've got our delta E, that's our change in energy, is equal to HF? Ooh, it's there. It's there, guys. Oh, what a surprise. It has to be there because it's a key fact consequence thing, right? And then since there are only certain energy changes possible, only certain frequencies are possible. Can you see that's the consequence of having these discrete... Whoa! And we got all of them, all those 5 points. I mean, we didn't write them down, but we did think about it. Can you see now that explain isn't woolly? It's very specific, very specific. And if you really understand what is meant by explain, you can figure out what's going to be on the mark scheme. Okay, right. Right, I've got a bit excited then, sorry. So I'm going to go back to my PowerPoint because we need to move on. Right, so the next bit then is the learning loop. Okay, so the learning loop then is my 3-step process. So some of you will have seen in the ad, maybe your mum or dad found the ad for you, so you might not have seen it. But the learning loop is this, okay? 3 steps. So first of all, you do a past paper or at least an A-level question. And you find out what you don't know because you didn't get it all completely right, okay? And but you've got to figure out, and this is the bit that most people don't figure, you've got to figure out if the thing that you didn't know that meant that you got it wrong was physics or exam techniques. Oh, it's probably that one. Okay. And then you've got to fill in the hole in your knowledge. Okay. And that's the bit that most people don't do. So they they do the papers, they mark them themselves, they don't get all the marks, and they then go away and think it's the physics, and it probably isn't. It's exam technique, and you've got to figure out what it was about your answer that didn't follow the instructions that were given to you on the paper. Okay, so that is the learning loop. So you do a paper, you find out what you don't know, you fill in the holes in your knowledge, and you do another paper, and that's a loop. You go back round it and around it and around it, and the more times you go round the loop, the better your score will get. Okay, and ideally you do whole papers, you do them timed in exam conditions with your data sheet and your calculator that you're going to use in your real exam. If you get extra time, give yourself extra time. If you get a scribe, preferably have a scribe. That depends how patient your parents are, probably, but honestly, you want to do everything exactly as you do it in the exam, because you've got to practice all of the exam techniques. You've got to practice timing. You need to know how fast is fast enough. You need to practice changing when you go from multiple choice to structured questions, because at some point you're going to get your maximum marks, and you've got to recognize that it's a game. You're swapping your minutes for as many marks as possible, please. So it's not money for goods, it's minutes for marks. And if you did nothing but multiple choice, you wouldn't get maximum, and if you did nothing but structured, you wouldn't get the maximum you could possibly get. So in there somewhere, and all of you are maths people, in there somewhere, there's going to be the correct time to swap from your structured questions to your multiple choice. And I would recommend that you do your structured questions first, because your marks per minute rate is probably higher on structured questions than it is on multiple choice. Okay, so that is the learning loop. So you don't ever sit down and revise. Did you ever hear me say revise? Don't get me wrong, this is not the same as not learning things in the first place. You absolutely have to learn things in the first place.
And if you find that you have a hole in your knowledge,
then you go away and you make sure that you fill that hole in, if it's physics. Yes. But you don't ever watch videos you don't ever write flashcards, or because there are 0 marks for the best flashcards. There's 0 marks for the person that watched the most physics videos. There's 0 marks for even the most amazing mind map. Honestly, the only thing you score marks on for is being able to do A-level physics questions. So that's what you've got to practice. Okay, so there is the learning loop. Right, so now we've got some bits and pieces. Right, okay, I want to give you something. Let me escape from there a minute. I want to give you something that will help you with that learning loop. Obviously, you need papers, right? So, there's free stuff, right? So, go to any of the pages on my website and scoot down to the bottom, and where you want to go to, the Knowledge Centre blog thing. And either click on it or hover over it so that you can get to the work plans. Click on that and it will open this page, okay, on my website. And what you've got to do is you put in your details and then pick the right work plan for you and agree to be sent it by email and submit. And then you will be sent a work plan, and it will look, let's have that one. It will look I don't know, let's go for the AQA one. It will look like this. So it's just a spreadsheet, but with papers. Can you see that paper list is AQA papers, and that paper list, they're all hyperlinked. You can see that there's some legacy papers there, and then the right hand column, those are linked to the mark schemes, relevant mark schemes, and the furthest right column is just a list of dates. And if, I mean, it's put in there to start on the 15th of September, because that's next Monday, and that is when my exam techniques, essential exam techniques course is going to start. So, yeah. Right, if you look, I mean, some of you are obviously going to be much better at spreadsheets than me. That is just fed off that. So if you change that date, it will change all of these dates. So I could do that. Let me do it. Let's make it into today's date, shall we? So it's the 10th of the 9th, 2025. Right, and if you look at the start dates, they'll all change when I press return. There they go. Oh, ooh, it didn't like that. I think it doesn't like that. Oh no, look, it's got a thing in front of it. There we go. It had an inverted comma. I don't know how I managed to put that in, but anyway, okay. So there we go. So you can see that one is just 7 days more than the one above it. So you can change this. I mean, if you put 7, you could put I don't know, 5 there. And then you could just literally copy and paste it, pull it down, and that would be doing a paper every 5 days. And it would take you to the middle of December. These are AS papers. And sort of December time, you really need to start doing Year 13 papers, proper full A-level papers.
We've got a couple of questions.
Yeah.
Do you have any advice for multiple choice questions?
Yes, I do, but I'm not going to do it now. If you want advice on multiple choice questions, go to my free stuff page and go and look at the Autumn Accelerator Masterclass and scoot through the Ninja question analysis and go to the Improving Your Odds with Multiple Choice.
Paul's just said pray and roll the dice.
Pray and roll the dice. Well, funnily enough, one of the things that I advocate is eliminating obvious wrong answers and then guess, because it's a method of speeding up. Because multiple choice questions, quite a lot of them are designed to waste your time. So, and that's a legitimate exam technique. I am really sorry, but I don't have any EduCast work plans. I could potentially put one together, but I haven't got one ready for you now. I'm really sorry. So no is the answer to that. Right, okay. So that was that. What was I doing? Right, so I'm going to go back to my thing. Right, so this is now then bits and pieces. While I do these bits and pieces, perhaps you could call your parents back, because the next thing I want to do is to talk to parents. Oh, I didn't want to do that. Is talk to parents about how they can support you in your A-level, particularly with your UCAS entry stuff. Okay, so bits and pieces. So you've got to learn your data sheet, not the equations, but what all the symbols mean with no context. You need to learn your specification, again, not by heart, but you do need to know what you need to know. The specification actually says everything that you are expected to know. And they can ask you questions about stuff that's not on the specification, but they have to give you sufficient information that you can do it with your knowledge of what is on the specification. So yeah, knowing what's on your specification. So for example, the EdXL course, the specification includes the thin lens equation. The thin lens equation does not appear on the OCRA course at all. And it does appear in AQA, but only in the medical physics option for correction to vision, or the astrophysics option in telescopes. Okay, so knowing that means that if you come across on Physics and Maths Tutor a question on thin lenses and you're not doing EdXL, you can go, oh, okay, I can just leave that one. It's not relevant. Can you see that that's a really useful thing? I don't know. Anyway, learn your specification. I think that's important. Use your engineering button to change factors of 10 to the 3. So your engineering button, not all calculators have them, but this calculator does. It's there. Can you see?
So it doesn't mean English.
No, it doesn't mean English. It means engineering. Engineering notation is putting in factors of 10 to the 3. So for example, 10 to the 3 is kilo, 10 to the 6 is mega, 10 to the 9 is giga, 10 to the minus 3 is milli, 10 to the minus 6 is micro, and so on, right? So, and it puts it in factors of 10 to the 3, and you never ever, if you get a number that's really long, you never have to count decimal places ever again. Just press your engineering button. If you press it more than once, you can go one way. It does 10 to the 3, then 10 to the 6, and 10 to the 9. And if you do shift in it, it does the other way, and 10 to the minus 3, 10 to the minus 6, 10 to the minus 9. Okay? So that's really, really useful. If you haven't got an engineering button, I feel for you.
Sometimes you can have an engineering button, but it not be a physical button. Go into your settings, especially if you've got one of the newfangled graphing calculators that, like,
they're allowed, but yeah. Okay.
I've seen some that've got games on them. I can't.
Right, this year you are going to be using radians more than before. You need to use radians when you're doing circular motion and simple harmonic motion, and simple harmonic motion and circular motion come into other things as well. So electromagnetic induction comes to mind. And so yeah, you need to notice when you're in degrees and when you're in radians, because a radian's about 60 times the size of a degree. So if you get it wrong, you're going to get it really wrong.
Especially when you input it into a robot and then tell it
to
turn
oh, there's
60 degrees.
Anecdotal, yeah. Turn the robot 60 degrees and it does 60 radians and it goes round and round and round and round and round. Anyway, right, okay. Next. Use a pale highlighter pen. We talked about that with the Ninja question reading. Read the examiner's reports. I don't know about you, but the examiner's reports tell you where most people went wrong in a question. And I think that's really helpful. So you don't have to read all of them, but do read some. Okay, that would be really helpful. Right, okay, so we've done putting things in perspective, we've done physics is hard, we've done the importance of exam techniques, we've done Ninja question, explain and describe questions, we've done the learning loop, and we've got you your work plan. So now what we're going to do is advice for parents. I hope the parents are around. We're going to talk about navigating, well, the A-level journey in general. And in the run up to exams and UCAS in particular. Okay, so quiet, comfortable place to work. Quiet is really essential, and I would encourage you to do most of your exam practice in exam conditions. So complete silence, no phone in the room. Time yourself, use your data sheet, use the calculator that you're going to use. Oh dear. Healthy snacks. It's very, very easy to start eating chocolate biscuits when you're, busy studying. It would be better to eat, carrot sticks and stuff.
Bananas.
Okay.
Potassium.
Don't give up all of your, hobbies and stuff. You need to stay fit, so don't give up your sport. Not completely, maybe cut it down if you normally do football training 7 times a week. Maybe cut it down a bit, but don't give up completely, because a fit person who is fit and healthy, their brain works better. And so do a little bit of exercise absolutely every day, and don't give up all your sport. If you start struggling, in the first instance, ask for help from your school. The other students and other parents of other students might also help you. And obviously, if you get a tutor, then a tutor might help you too. But in the first instance, seek support from the school, especially if something comes up about exams. So for example, you have a bereavement, go and talk to your school's examinations officer. Because you can have special consideration. It's not actually worth all that much, but it's better than nothing. So yeah, if you think that you might be dyslexic, for example, or have some other, I don't know, ordering and processing problem that affects you. If you want to have extra time, you need to get it sorted out now, as early as possible.
So that
Ask,
you can,
yeah.
so that you can get used to using it.
Yeah, that as well, so that you can get used to using it, but also so that it's in place, so that you actually have more of a level playing field when you actually do your exams. Okay, so so that's the first instance, right? When you're actually doing exams, especially if you're on study leave, it's really, really tempting to go nocturnal.
Bad idea.
So you get up late because you don't have to get up because you haven't got to go to school. And so, and then you know, mess about and you get yourself something to eat, and you don't actually start working until sort of 4 in the afternoon. And then you think, oh, right. And it gets to about 10 and you think, no, I really ought to do some more because I didn't do any in the morning. And so you end up going to bed at midnight or 1 or 2 or 3, and you get up even later. And suddenly you find yourself waking up at 2 and 3 in the afternoon and going to bed at like 4 or 5 in the morning. And you've ended up becoming nocturnal. And that's rubbish, because you will never be firing on all cylinders, absolutely top notch at 9 o'clock in the morning when your exam starts. So you absolutely must get up. So don't go stock nocturnal. If you have a problem with stress, if exams cause you stress, go and ask for professional help early. And try various reduction techniques. Practice them. See which ones work. My sister is an exam phobic. She really struggles in exams, and she ended up having it was called relief remedy, I think it was. It was a homeopathic thing. She would just put drops on her tongue, and I don't think it did anything, but it made her feel better, even if it was just a placebo effect. Placebo effect is real. So do something about your stress. Actually, when you're having exams, make sure you have a good breakfast, preferably slow release carbohydrate and protein. It's really important. Yeah, bananas are good. A bacon sandwich is good. You know, eggs with eggy soldiers, toast.
Porridge.
Yeah, porridge. Anything that's going to carry on giving you sugars over a long period. So you know, sort of hash browns. I mean, a classic English breakfast, if you can stomach it, is really good for you. To brain food, right? Or one of those protein bars, you know, with nuts and fruit and stuff in it. Okay.
You can bring snacks in with you as well. They just have to be in a clear container and they can't rustle when you open it.
Yeah, they mustn't crunch or anything. Okay, so get to your exam early so your stress levels are minimised. You don't want to be sat in traffic going, I'm going to be late, I'm going to be late, because there's no way you're going to do your best work in that situation. And keep things in perspective. There's more to life than A-levels. I know this is a bit of a weird sort of place to say that, but there's always options, always. Okay. Right now, new UCAS. UCAS is a bit of a minefield, and they've changed things now. The personal statement, instead of being one continuous document, is now 3 questions. And but the content that you're expected to put in is pretty much the same. They've tried to make it easier, and I think it is a bit easier. I've spent some time just recently having a look at it, because one of the things, where you'll see in a minute when I offer you my my tutoring package, one of the things that I include is a critique of your UCAS personal statement. Anyway, so you need to know the deadline dates. The 15th of October is the deadline date for entry, for early entry. So if you're applying for medicine or veterinary, if you're applying to Oxbridge, if you're doing entrance exams, things like Imperial, they do entrance exams soon after the 15th of October. It's before the end of October. And so you have to have applied before that. So the 15th of October is the early entry deadline. And then the very last day of January is the late entry deadline. You can apply after that, but you won't necessarily have a level playing field. Having said that, I would recommend, even though they say it shouldn't make any difference, I would recommend that you have your UCAS, if you're going to apply this year, have your UCAS entry in before the end of the autumn term, because the people who are organising the courses, they're people. And if you were organising, you were the entrance person, the admissions registrar for a particular course, you'd want to have your course pretty much filled before the end of the autumn term if you possibly could. And although you wouldn't have sent out the offer letters yet, you would know, well, we'd like that one, and we'd like that one, and we'd like that one. And if your entry isn't there, then they can't kind of earmark you. And so although it shouldn't make any difference, I would recommend, because these admissions registrar are people, that you apply before the end of the autumn term if you can, just in case it does make a difference. Okay, so now you can enter afterwards, and you can apply for clearing even if you didn't enter at all. Okay, so so knowing the deadline dates is important. I do have in my knowledge centre on my website, there is a whole thing on UCAS. So I would go and read that article if I were you. Encourage your child to record the extracurricular stuff. So Duke of Edinburgh, volunteering clubs and societies, sport, travel, courses and lectures. People have a tendency to think that hobbies shouldn't feature because, oh, they're not very worthy. I don't know, maybe you're brilliant at crochet. Megan does crochet, she's amazing crochet. But you think to yourself, well, I want to apply to do mechanical engineering, and that's got nothing to do with crochet. I'm not going to crochet. I'm not going to mention it. Yeah, crochet. Yeah, but it is relevant because, especially if you are if it's a hobby that you've had for a long time and you're actually very skillful at it. I mean, it means that you're a self-learner. It means potentially, it depends what your hobby is, but it means that you are resilient. It means that you are reliable. It means that you are consistent, right? The person that has the same hobby for many years is much less likely to spend 2 weeks on their degree and go, yes, this is not for me. Okay. Can you see that, if you do, I don't know, martial art and you look after the little ones, that means that you're trustworthy. Okay, so they trust you to keep children safe. Can you see that this is, you might not think that this is important, but absolutely it is. Anyway, so keep a record of all your extracurricular stuff, whether it's travel or courses or lectures or books or whatever it is. Get a support from the school and other students and other parents to help you with writing your UCAS personal statement and stuff. Apprenticeships can be applied for through UCAS, but not all apprenticeships are available through UCAS. Dyson is one in particular. You have to apply direct. And the deadline dates for apprenticeships, even if they are in UCAS, are not the same as the deadline dates for applying to university. So do your homework, go and find out when they are, figure out what you'd like to apply for. And I don't know about you, but apprenticeships seem to me to be brilliant. I mean, you quite often you get a job while you do your degree. You get a degree. They pay for your degree, so you get no debt. You get paid while you're doing your degree, so you've got some money to spend. You do spend, I don't know, day release or whatever at the university, so you do still get the social life and get to meet people, and you get a job afterwards. So no debt. I mean, why wouldn't you do that? And anyway, I just think apprenticeships are great. Consider not applying till next year. I think that for most people, having a year away from academia and the blinkered GCSEs, blinkered A-levels, blinkered degree, blinkered good job, blinkered buy a house, blinkered have a family, blinkered. It's like, well, when do you get to enjoy your life? You've got to enjoy the journey. And I think that having a gap year, if your family supports it, if you can afford to do that, I think that having a gap year learning about being bored, learning about the value of you know, getting a job at stacking shelves, or you know, a barista in Costa Coffee or whatever, earning enough money that maybe you can do a little bit of traveling, go off, you know, camping, or interrailing, or with your friends, find out about something that's not school, that's not academia. Just gives you a completely new outlook on life. And I think that that's a really valuable thing to do. So consider that. You don't have to, but obviously it's a personal preference. Okay, UCAS statement, personal statements, all sorts of things can go in there. Your travel can go in there too. Okay, so the huge numbers of options open to students. There are always options, even if they fail. Things other than A levels can count towards UCAS. So your EPQ is worth like half an A level. Drama and music qualifications, if you've got like a grade 7, I think might give you something, or 8 anyway, definitely surely does.
I think
Gives you
UCAS
points.
I think 6 and up. 6 is like not many UCAS points, but like 7, 8 definitely. If you do diploma, that's essentially a foundation year level at uni.
Anyway, so those things can give you help towards your UCAS entry. You don't have to go to
don't forget DOV.
DOV, yeah. You don't have to go to university straight away. You don't have to take up your place straight away, even if they offer you one. So you can defer. Not all courses and all universities will let you do that. So if you are thinking you might want to do that, then you will need to check. So your particular university. Think about having a proper safety net. So many people go, right, well, I'm going to go to Bristol or I'm going to go to Bath. And there's like 1 grade difference between the offers. And it's like, well, that's not a safety net. You know, you only have to have a bad day and you drop from an A star to a B. That's that. It's anyway. I think that having a proper safety net, so have one where you really, really want to go, and one which you really like, but that's significantly lower grades. Okay, as a proper safety net. Consider a gap year, sponsored apprenticeships and foundation years. So if you fail your A levels, rather than resit, I would recommend a foundation year. Carefully consider the type of university as well as the learning environment. So campus versus city. London accommodation is very expensive, but if you've got family in London, maybe that would be better for you, and so on. You can always change your mind. Yeah, keep things in perspective. Right. Okay. That is it from the point of view of the valuable content. What I'm going to do now is I'm going to tell you about my own courses. If you have no interest in investing in tutoring with me, then obviously I'm not going to keep you, but no one will mind if you go. Okay, but if you are interested in finding out what I've got to offer, then please hang on and I will tell you about a really quite a special offer that I'm doing at the moment. Okay, and it is called the Complete Cosmos Physics